All right, welcome back. Let's go ahead and take a look at those last couple of problems. I'm pretty tired. It's pretty late in my day right now, but hopefully we'll get this thing dialed in and put things squared away. So here we go. Let's see. I need to get over to my visualizer. So let's see what we got. So this looks like kind of a sign of something minus something else. So our little formula for that was the sine of alpha minus beta is kind of what this thing looks like. And our formula for that was the sine of alpha, the sine of the first, times the cosine of the second. And in that formula chart, if there's a minus in the middle, then there's a minus here as well. And that's different than the cosine. And then it goes cosine sine. Okay. Now, of course, that means we've got the sine of alpha and the cosine of pi over 6. And then we have the cosine of alpha, but the sine of pi over 6. So I wanted to write that because that looks a little bit different than the other problems. And in fact, I just realized I didn't really want to write cosine of alpha. I really wanted to put a parentheses there because the cosine of alpha is something I can refer above to go get. So keep in mind, if we look above, I want to know the sine of alpha. And if we look right here, I know that the sine of alpha is opposite over hypotenuse, which is negative 40 over 41. And keep in mind, the cosine is 9 over 41. So it's negative 40 and positive 9, but both over 41. So this is going to be 40 over 41 and 9 over 41. And of course, the last little piece of that puzzle is that we know that the cosine of pi over 6 is root 3 over 2, and the sine of pi over 6 is 1/2. So both of these have a denominator of 82, and they would have a numerator of negative 40 roots of 3, negative 40 roots of 3 minus 9. And we're done. That's literally all there is to it. Now, when we go over to the cosine, this is one of those things where answers will vary. There's no particular reason why I picked a cosine instead of a sine, but I guess my eyes just went to the cosine first. So this says, go find the cosine and then square whatever it is that you get and then subtract 1, right? So if we look up at the top, the cosine would be negative 1 over root 10. Well, that's not too bad of a problem. Negative 1 over root 10. And of course, if I square negative 1 and if I square root 10, I get a pretty nice little answer set, don't I? And so I have 2/10, also known as 1/5, minus 1, which of course is 5/5, and 1/5 minus 5/5 is negative 4/5. We're done with number 21. Cool. Now, go into this one. Now, I mentioned this in the above one. Notice the minus here leads to a minus there, but the cosine of alpha minus beta goes cosine, cosine. And if there's a minus in the middle, the formula tells me to add the two things. So we're going to have to go through this process. And now the downside is I have to keep referring back and forth to something that's pretty far away. So let me see if I can maybe fold my paper so I can have it close enough that we can see what's going on. So maybe that would be a good solution so that I can see what's going on. This asks me to go find the cosine of alpha, which of course is right here. This one says go find the sine of alpha, which of course is right here. And then it says go find the cosine of beta, negative 1 over root 10. And over here, last, it'd be the sine, which is 3 over root 10. So it looks to me like I've got negative 9 minus 120 all over 41 roots of 10. So that looks like negative 129 over 41 roots of 10, which of course we're not supposed to leave the stupid root in the bottom. So we're going to multiply the top by root 10 and the bottom by root 10, and we're kind of done. And last but not least, our final endeavor, getting tired here, but the formula for a half angle is 1 minus the cosine of that angle divided by 2. And this problem is a smidge irritating because when you go to find the cosine, you get a negative 1 over root 10. Well, that's a big problem because we have now a root inside of a root, and we also have a fraction inside of a fraction, and it's a root in the denominator. That's just horrible. It's like everything that could go wrong is going wrong. So I suppose we should multiply the top by a root 10 and the bottom by a root 10. But then we still have a root in the denominator, don't we? So if we multiply the top by root 10 and the bottom by root 10 inside the radical, keep in mind this is all inside the radical. Root 10 times root 10 is 10, times 2 is 20. And then up top, root 10 times root 10 is 10. Now we're getting better. I will say we are definitely getting better, but the last thing is we still technically have a root in the bottom because that's the square root of 20. Shoot. So I got one last little trick up my sleeve. I'm going to multiply the top by 5 and the bottom by 5 because if I multiply by 5 right here, I have the square root of 100, which is 10. And so if I multiply by 5, I get 50 plus 5 roots of 10 over 10. Now, the other thing that I wanted to mention is this is the plus or minus, right? But if my angle beta right here, this is why I said that, beta is somewhere in here, and I cut it in half, that means somewhere beta over 2 is somewhere between 0 and pi over 2, which is in the first quadrant. And so if this is in the first quadrant, that definitively tells me I'm going to pick the positive answer throughout because everything is positive in the first quadrant. And hey, we finally finished that review. Hopefully that was helpful. I'll see you back in class later. Bye-bye.